Hi everyone. In this presentation, I'd like to discuss about my progress on this project. That is to investigate continual learning methods on the Tedlium speech recognition model. So previously, we've proposed two methods to look into. The first one is elastic weight consolidation, and the other one is replay. So we've done several experiments so far. The first thing we did was to prepare a set of data conversion scripts to fit the SSI dataset into the Tedium format. Just because the SSI corpus dataset store things differently than Tedium, so we have to do some unifying. And later on, after that is done, we performed basically four parallel experiments. The first thing we did was to use the given pre-trained model to directly perform decoding on the SSI dataset. The next experiment was to fine-tune this pre-trained model on the SSI dataset and then perform decoding. The third one, which is actually a unsuccessful one, was to introduce elastic weight consolidation into this fine-tuning process. It is unsuccessful because of two reasons. The first thing is that it's relatively complicated to introduce elastic weight consolidation within the Kelly framework. However, the most important reason is that EWC requires extensive training on the O domain data for it to be effective, for it to be useful, actually. But I think this is against our intuition because most of the time, we don't really have access to data from the O domain, and it can also be very costly, as in this case, to train on the O domain data. So we consider this approach as unsuccessful. And a final experiment we did was to introduce replay to the fine-tuning process, and then we fine-tuned this pre-trained Tedium model and then perform decoding. So again, the data sets we used in this project are the Tedium 3 dataset, the ICSI corpus dataset, and the ICSI replay dataset, which is just a augmented version of the ICSI corpus dataset with the introduction of about 10% of training data from the Tedium dataset. And we got the following results. So when we directly use the pre-trained model to decode the SSI data, we can see we got the highest error rate among all three experiments. And when we fine-tune this pre-trained model a little bit using the ICSI dataset, we can see that its error rate decreased by about 10%. However, we can also observe that the error rate for the Tedium dataset increased significantly, and that is due to catastrophic forgetting. Finally, when we fine-tune the model with replay, even though we didn't really get a huge increase in the accuracy of the SSI dataset, we did observe that the error rate for the Tedium dataset significantly decreased, which proves the efficacy of this continual learning approach. And one thing I like to discuss here is that among all these three experiments, the word error rate for the ICSI dataset is they're all quite high, and I think that that's due to several reasons. First of all, when we are generating the I vectors for the ICSI dataset, we try to reuse the Gaussian mixture model from the Tedium data, and I think this causes some side effect, just because this GMM is not able to represent the speaking characteristics of ICSI dataset accurately, and that led to inaccurate I vectors and therefore an inaccurate model in general. And also, the training data we have with the ICSI dataset is quite limited. We only have 50 hours of training data, among which only 80% are used for training. And also, we suspect that our training configuration is also suboptimal. So some future improvements we can work on is definitely we should try to optimize our hyperparameters for this fine-tuning process. And also we should try switching to a GMM generated on the ICSI dataset so we can produce more accurate I vectors and therefore more accurate models. And the final thing is to explore the applicability of applying learning without forgetting to this fine-tuning process. This is actually something I've been working on at this very last stage of the project so very recently, and I'm not able to finish due to time constraints. But I think this method is also very promising as learning without forgetting also does not require the data from all domains. So our current roadmap is to first of all use Kelly Onyx. So that's a open source third party tool that can transfer the Kelly chain model into a Onyx model. We can then further transfer this Onyx model to TensorFlow model for more customized adjustments in terms of the model structure. And then within TensorFlow, we can reconstruct the upper layers of this model and introduce a learning without forgetting loss, and finally train or let's say fine tune this model with the ICSI training data. So this is something that we can consider working on in future projects.